All right, girls and boys. So today we're going to take a look at addition once again. We are going to review some of the strategies that we've used throughout the school year. Some of these strategies are very similar to each other. They kind of go hand in hand. So I'm going to kind of point that out as we are moving along here. One of the first strategies that we learned, I think we learned this in second grade, is the partial sum strategy. And that's where you take, like if you're doing 34 plus 17, you take the 34 and you decompose it into 30 and 4. And then you take the 17 and decompose that into 10 and 7. And then you add up the tens place of both of the numbers. So you'll notice these blue arrows show the tens place from the 34 right here is 30, and the tens place from the 17 is 10. And then the red arrows represent the ones place, so the 4 from the 34 and the 7 from the 17. And we find the sum of the tens place, you find the sum of the ones place, and then finally you find the sum of the tens and the sum of the ones. So 40 plus 11 ultimately equals 51. You're basically doing the same thing with the base 10 blocks over here. You have the 34 broken down right here. Like if you notice, this is 34 and this is 17. So what you have is the tens, the 3 tens from the 34 plus the 10 from the 17. And then you have the 4 ones plus the 7 ones from the 17. And then you find that exactly how this was handled over here. So then once you have the 40 and the 11, you add your 11. 10 of those 11 form a 10 and add it up over to this side. So you end up with 5 tens, and then there's just one left. So you can see those two strategies go hand in hand. They're very similar. And then this one is basically what we were doing right here. When we do the traditional algorithm, it's this step right here. So we add up the 7 and the 4 just in the ones place, and we always start in the ones place with the traditional algorithm. Some even call it the old school way. So 7 plus 4 is 11. You put the 1 from the 11 in the ones place, and then the other one from the tens place above the other tens, and then we just simply add these up right here, 3, 4, 5, and you get 51. So when this part right here, this step where these 10 from the 11 were regrouped and changed back into a 10, that's what we were doing here when we were kicked this 1 up over the tens place. So I feel like the traditional algorithm also goes hand in hand with these. I'm going to skip down to this middle part. The open number line, that's when you take the big number of the two that you are finding the sum. So 34 is the larger of the two, and you put the 34 on the number line. Then you are going to skip forward 17 spaces, and you can do jumps of friendly numbers. So 34 plus the 10 from the 17 gets you to 44. And then 45, 46, 47, 48, 49, 50, and then 51. So we have 17. We added on 17, and our answer is what we landed on, the 51. So that's another strategy. And then the give and take, I think basically this strategy and this strategy, they're basically what I call give and take. I like this version better, so I'm not even going to bother with this. If you want to pause the video and analyze it, go for it. But I'm going to just focus on the one that I think is easier spelled out, a little bit more user friendly. So if we're doing 34 plus 17, if you take a look at 34, how far does 34 have to go to become a friendly number? Well, it's on its way to becoming a 40. That's the next decade. So, and if you know your tens complements, 4 plus 6 will get you there. So what we'll do is, to make this 34 into a 40, which will be easy to add, we're going to actually borrow from this 17, the other add end, and we're going to take 6 from the 17 and add it to the 34. So essentially, we're minusing 6 from one side, but we're also adding the 6 to the other. And that way we get to work with easier numbers that we can find the sum in our head. I don't even, for 40 plus, if someone said, hey, Mr. D, what's 40 plus 11? I don't even have to write that down. 40 plus 11, because there's a 0 in the ones place, so we know the ones place is going to stay the 1, and then all I have to do is know 4 plus 1 in the tens place is 51. So that's why give and take is such a cool strategy. It doesn't work for every situation very well. There are some situations where give and take might actually make it a little bit more complicated. But when you see that one of your addends is close to a friendly number, you should look into taking from your other addend and giving it to it just to create an easier problem. So we're solving 40 plus 11, but it's going to have the exact same answer as 34 plus 17. If this was on like a balance scale, 34 plus 17 is equal to 40 plus 11. Now, which side is easier to solve, though? 40 plus 11 is easier because it has a friendly number. So we're going to take a look at some problems here. This is the same problem. One is written horizontally, the other one stacked. And we'll think about a good strategy. So do I want to, for this one, I could break it up into the hundreds. So we have a 300 plus a 100. That would be 400. And then we have our tens. We have a 40 over here plus a 10 here, which would be 50. See how I'm decomposing it. So this might be a strategy that's useful for this problem. And then 8 plus 1 in the ones place is 9, so our answer is 459. Okay? And then this one, another thing I noticed about this, if you stacked it, there is no regrouping in this. Every single sum is going to end up less than double digits. So in other words, every place value sum is going to be a single digit number. You don't have to worry about having a double digit where you have to kick anything up here. So like 8 plus 1 is 9. 4 plus 1 is 5. 3 plus 1 is 4. So, excuse me. So we don't have to do any regrouping where we kick any ones up. You don't always have to do that. There are some students who sometimes think, oh, well, now that I learned regrouping, everything regroups. No, it just depends on the situation. So either one of those strategies would be good for that problem right there. And then I have another problem down here. This is 24 plus 69. And when I look at 24 plus 69, I'm noticing the 9 is a rather hefty single-digit number. It's right on the cusp of becoming a double digit. And I know if I added the 9 and the 4, that we're going to have to regroup if I stacked it. So for this particular problem, 24 plus 69, I don't think I wanted, my go-to isn't going to be the traditional algorithm. My go-to is I want to make this into a friendly number. So what I'm going to do is I need to add 1 to 69. And where am I going to get that 1? If I simply add 1 to it, then I'm changing the entire problem, and the answer is going to be, it's going to be too big. But if I pull from one addend, I take from one addend and I give to this one, basically I'm minusing 1 from here and adding 1 over here. My new problem is 24 with, that's 1 less, is 23 plus 70. All of a sudden, this is a mental math problem. 70 plus 20 is 90, and the 3 doesn't change. So it ends up being 93. Now, that's not to say you cannot do it with the traditional algorithm. In order to do it with the traditional algorithm, you can do 4 plus 9. Well, 10 plus 4 is 14, so 9 plus 4 is 13. And then the 1 that you would put here for the 13 gets kicked up here. So we have 6, 7, 8, 9. 93. So you can do the traditional algorithm. It definitely works. But for this instance, in my opinion, give and take is a lot easier. So hopefully that helps you with today's math lesson. You guys can always come back and take a look at how I solve these problems to help you with your addition today. Thank you very much and good luck.